Okay. So we're looking at the sum of the terms of an arithmetic sequence. Let A sub n be a arithmetic sequence. This guy, remember, I called the sequence generator. That's the guy that makes the list. With the first term A, which I called A sub 1, and the common difference D, then the sum S sub n of the first n terms. Now, if we were being tricky, right, then we'd play with this phrasing, and I'll kind of show you what I mean later on. But first n terms, that means first term, second term, third term, fourth term. It's the first n terms. It starts with the first one. Doesn't start with the fifth one. It starts with the first one. Of the first n terms of A sub n is these two formulas. And you're going to say, well, how do I know which formula to use? It's what information you have. N is the number of terms. That's the number of terms that you're adding up. So that says that would be the sum of the first 5 terms, sum of the first 10 terms, sum of the first 15 terms. This is the first term, so that's A sub 1. There's the number of terms, and there's the common difference. That says if I know what the first term is, and I know what the common difference is, and I know what the number of terms I'm adding up are, I could use this guy. Because that's the thing I need to fill in. Or the equivalent is n divided by 2, A sub 1, A sub n. This is the first added to the last. If I know the first and the last, and I know the number of terms, that's n, I can use this guy. Depends upon what you have. In this particular instance, on this one, I have the first and the last. But the problem is I don't know how many terms there are. Because it's 5 plus ... plus 59. How many are there? I haven't a clue. But I can find out. Same thing here. Here, I'm just given n. How many terms are there n? It's going to come out to be a formula. Where this is the sequence generator. That guy's the sequence generator. So that says, find the sum. Well, because this is just n, I could use this guy. Because I know the first and the last, the number of terms is n, it's general. So it's a general formula. So I would say that S sub n equals n divided by 2, because I'm going out n positions. And I'm going to add the first and the last. Now notice what it does is that if you knew what n is, it generates that last value. Because you put a number in, it gives you the number that's in that position. So clean it up. So it's n over 2, and it's minus 1 minus 5, so this is going to be 4n minus 6. You could leave it that way if you like, but that's not the way you would see it in the book. The book would multiply through by n over 2. This would be n over 2 times 4n minus n over 2 times 6 using the distributive property. This becomes a 2. This becomes a 3. The formula that you would see is 2n squared minus 3n is the sum of the first n terms. I'd take this guy. Man, I don't care. Well, it's going to be in the multiple choice section, so it's going to be whatever is there. Okay. So it's 2n squared minus 3n. And that's what you would see in a book that says, if my sequence was of the form, and this is the a sub n, the sequence generator is 4n minus 6, and it'd have to be specifically in that form, then you could use this formula to add up the terms. You tell me how many terms you want to add up, you'd use this formula. This formula is attached to this sequence. Or, in other words, you could also look at it this way. This is the sum from k equal 1 to n of 4n minus 6. So that's the way you would see it in summation notation, because the sequence generator goes inside the summation. It's generating out the terms that you're adding up. And then what would it be? You just tell me what n is, I'll tell you what this adds up to. That's essentially what this is saying. And of course, this is your answer. Now this guy is all numbers, so he's trickier. The problem that I have is in my formula, here I have the first term, I have the last term. What I don't have is the number of terms. So that says I can use this formula that S sub n is n over 2 a sub 1 plus a sub n, and I have n as a variable, a1 and an. I don't know what n is, but I do know what I need to know what n is. A sub 1 is 1. A sub n is 59. That's the first plus the last, but I got to find n. In either formula, I need to know how many terms I have. Well, that's easy enough. And you're going to say, well, why? Because I know that the last term is 59. So if a sub n is 59, I need to know what n generates that number. So one thing we remember or don't remember from our formula sheet is the sequence generator can be found by taking a sub n is a1 plus n minus 1 times d. So that says that 59 equals a sub 1 plus n minus 1 times d. Do I know what a1 is?
1.
Yeah. I don't know what n is. I need to find that out. What's d?
2.
Yeah, I go from one position to the next. 5 minus 3 is 2. So that's d. Now I can solve for n. Everything else is numbers. So I get that 60 equals 2n minus 2. This had better be an integer, because remember, it's a position number. So that 62 equals 2n, or n is 31. So this is the 31st position. So that means that this guy can now be filled in. N is 31. I'm finding the sum of the first 31 terms. So what is this guy? S sub 31 equals 31 divided by 2 times 60, which is 31 times 30, and 31 times 30 is a number, and I could do it in my head, but I'm not going to trust myself to do it in my head.
How did you go from 59 to 60?
Pardon me?
How did you go from 59 to 60? And the-
Because it's the first term plus the last term.
Oh, okay, great.
So it's 1 plus 59, which is 60. The number of terms divided by 2 times the first plus the last. I didn't know what the number of terms is, but I know I'm going to divide it by 2 once I find it. The first term is 1, the last term is 59, and then 1 plus 59 is 60. And then the sum of the first 31 terms is 930.